Hey guys, we're going to go assignment 8-1, multiple choice 23 through 26. So let's do it. So the first question here says, a researcher is deciding between a 95% confidence level and a 99% confidence level and comparing the two. So imagine that we did the data we collected, right? And notice one standard deviation is about 68%. But most people wouldn't like 68% confidence. So we want to multiply that standard deviation. We want to widen this so we can become more confident, right? And so notice we learned last class that the 68, 95, 99.7 rule states that just rounding about one standard deviation from the mean is 68% of the data. About two standard deviations from the mean is 95. And then, so that would mean 99.7 is 3 standard deviations. So I wrote out these critical values from the table just so you could kind of see what this means. So if we decided to pick compared with the 95, if we decided to pick a 99, then the 99 is wider, correct? So I'm canceling A and C here, right? And then would it involve a smaller amount of risk or a larger amount of risk or the same? So we notice here that this would involve a smaller amount of risk because I'm wider, correct? Because you're 99% confident, which is more confident than 95. So you're less at risk. Here, you're like 5% at risk for being wrong. Here, you're only 1% at risk for being wrong. So that's a smaller risk. All right, now looking at number 24, it says, after deciding on the 95% confidence level, a researcher decides between 500 and 1,000. When we compare the two, what will that do using a confidence level? So we're keeping our confidence level at 95%. So that means that we're going to have the same risk. We're not going to have a larger or smaller risk. So I'm actually tending to pick E, but let's also verify that it's narrower. So if you notice here, all things being equal, that when we divide by a bigger number, so if instead of dividing by 500 here, we swapped out 1,000, that all things being equal, meaning P hat's the same and Z star is the same and our point estimate's the same, then whenever I divide by a bigger number, it's going to make a smaller number. So that will overall make our margin of error smaller if we divide by the number 1,000 instead of dividing by the number 500. So we know that our sampling distributions, and actually anytime we make n bigger, then it makes things narrower. And that's been true in all the previous chapters as well. So when n gets bigger, your distribution is narrower. Okay. Now, 25. In a poll conducted by the phone, some people refused to answer the question. So that's just kind of non-response, right? People without a telephone couldn't be in the sample. So that's under coverage if you can't get to them. And here, some people never answer the phone in several calls. So that's maybe a combination of both. Which of these is a possible source of bias that is included in our margin of error? And so we definitely want to pick none of these. And again, the reason for that is what's inside the margin of error is variability alone. It's not for mistakes or anything like that. And we said that in our notes, right? So here were our notes from last class. It says the margin of error does account for sampling variability. It does not account for non-response, under coverage, and response bias. Okay? Last one, 26. So 26 says you measured the systemic blood pressure of a simple random sample of 25 company employees. Based on this sample, you created a 95% confidence interval for this measurement of the employees, and you created this interval. Which of the following statements is true? So we know that we can go with our script, right? We are 95% confident that the interval from 122 to 138 captures the true mean systolic blood pressure of company employees, right? But that's none of our choices, because what they're not asking for just to interpret it, they're asking for what it actually means. So going back to our notes, right, we notice that here is our script, right? And that's when we're asked to interpret the confidence interval. But when we're asked what it means, that was our second set of notes. So we notice here, it means that if we take many, many samples and calculate a confidence interval for each, that about that percent of them would be capturing the true parameter. So when we look back here, we notice we like these words, many, many, right? We cast off these, and then we dig in. So if the procedure repeated, 95% of the resulting confidence intervals would contain that true mean. Yeah, so that is our answer C. So why is D and E not correct? We see that if the procedure, 95% would be between there. No, we're not saying that at all. Again, think about the nets we cast. So we created these nets, and we got a lot of variability. We did that just here in our last class. And essentially, we're saying that if this is the truth, notice that one was not captured, if this is the truth. So that's what we... systemic blood pressure. That's essentially what we're saying, that 95% of these confidence intervals we create would contain that true population mean. It's not to say that you're locked into this 22 to 38. That's not what we're saying here. Similarly, 95% of the time, the sample, again, we're not repeating this many, many signs to say something about a sample. We know each sample is unique. Each sample provides a little piece of information. And no one sample, like, so let's say this sample is 122 to 138, and this sample is 131 to 143. Notice, no one sample is providing any earth-shattering information. It's the accumulation of the data we've collected that gives us this confidence. Thanks for joining me, guys.